Hello everyone. Today we're going to be working with Lewis structures. Lewis structures are a great way to visualize a molecule and understand the way the atoms that make up that molecule bond with one another. To start, our first example will be ammonia, NH3. When thinking about making the Lewis structure for a molecule, it's important to consider the electronic configuration of each atom. We'll start with nitrogen. We know nitrogen has 5 valence electrons, and we also know that it has 7 total electrons. So we want to find a way to put these 7 electrons into orbitals in the most stable way possible. We'll start by adding 2 to the 1s orbital, 2 to the 2s orbital, and then, because there are 3 p orbitals of equal energy, Hund's rule says to place 1 in each before pairing them up. So we'll place 1 in 2px, 1 in 2py, and 1 in 2pz. When considering hydrogen, it's very easy because there's only one electron in the 1s1 orbital. Next, to show the Lewis structure, we'll start with nitrogen, and it has its 5 valence electrons. Next, we'll bind each hydrogen. 1 here, 1 here, and 1 here. You'll notice now that nitrogen has an octet, meaning that there are 8 valence electrons, or shared bonding electrons, in this case with hydrogen. This is the most stable configuration. Another way to draw this would be N, H, 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 which with each dashed line representing a bond. The next example we're going to use is H3O+. We want to consider the total number of electrons when doing a Lewis structure, so this plus charge here is very important. It means that there's going to be 1 less electron. So we'll be getting 6 from oxygen, and then 3 from the 3 hydrogens. And then we have to subtract 1 because of the plus charge, leaving us with 8 total electrons in this structure. So we'll start with oxygen, and we're only going to put 5 around it because we have 1 less electron, as we saw from the plus charge. We'll bond a hydrogen with each of the unpaired electrons on oxygen, and now you see oxygen maintains an octet, and this would be the Lewis structure for this molecule, also shown as this. So, our last example is going to be CH3OH. So first, like we did last time, let's count the total number of electrons. 4 from carbon, 4 from the 4 hydrogens, and 6 from oxygen, giving us a total of 14 electrons. So we'll start with carbon. It has 4 electrons around it. Bind a hydrogen to 3 of them. And then add oxygen. 1, 2, 3, 4, 5, 6. So now carbon has an octet, but oxygen still has 1 unpaired electron. This is where we'll add the last hydrogen. Now each carbon and oxygen have an octet, and just to be sure, let's count the total number of electrons. 2, 4, 6, 8, 10, 12, 14, just as we expected. So this would be the stable Lewis structure for this molecule. Lastly, here are some problems to do before class to bring them in for credit. First, C3H8, then CH3, CH2, CH2, Cl. Next, CH3, NH, CH3. And lastly, CH3, CH2, O, CH2, CH3. Good luck on these problems. I'll see you in class.